Hi everyone, it's Simon Wilmann from VMware. I'm based down in Melbourne, Australia, and I'm a cloud management specialist. I've been for VMware about a year, and before that I was working for one of Australia's big four banks for about 10 years, taking care of all of their virtualization. But what's that got to do with blockchain? Not much. One of the reasons I got into blockchain was around 2013. There was that big price spike and it was in the news everywhere and a lot of hype. And I'm like, what is blockchain? Why is everyone so hyped up about it? And so I started researching and finding out what it is. And I quickly realized that if you want to get into blockchain, it's a good idea to understand exactly how it fits together. Why is it so unique? What makes it special? And knowing about analogies of like little villages with rocks and things like that that use it to track their money kind of helps, but it's not really where you want to be if you want to start working in the space. So I'll give a little bit of an overview of what a blockchain is. It's a pretty simple thing, but done in a special way. It's essentially just a ledger, a list of transactions or whatever you want that you don't have to trust everyone has a copy of, that's secured with a bit of cryptography. And that's basically what a blockchain is. Everything else around it is different ways of doing this. But I know it's a bit confusing, but I'll break it down to something that's a bit easier to explain. So when blockchain was first, or Bitcoin was first created, a guy called Satoshi Nakamoto, or a pseudonym, just not sure if it's one person or multiple people, no one really knows who he is, created around the GFC, the global financial crisis, and people's subprime mortgage crisis, and banks were foreclosing on people, taking money away from people, and he's like, there has to be a better way to transact money without having to trust a single party like a bank or PayPal, like people getting their PayPal accounts frozen, or anything else. So literally when you do a transaction now, or you want to send money to somebody or anything like that, you're not the one doing it. It's the bank. You're just asking the bank to do it on your behalf. And that leaves you vulnerable to the bank being the central hold of everything and having a denial of service or being compromised or corrupt or whatever. With a blockchain, you're not doing that anymore. You're directly connecting with the person that you want to actually send money to, because everyone is holding a copy of the ledger. There is no middleman, and you own what you're doing. You become the bank. You become the person who facilitates all this. So how does that work? How does that work in a real analogy between technical and realistic? I'll try to bring it to a bit of an easier concept to start off with. If you had a bunch of friends and you were going to dinner, or often multiple times, and you couldn't split the bill, or you wanted to split the bill, sometimes you would one person would pay the bill and you'd owe them money. And the way you would do that with a group of friends is probably maybe write it down. So you could have things like Alice pays Bob, Charlie pays you, or Bob pays you. In a small group, that works well. But the issues with that is it's very hard to scale that to more than about 4 or 5 people. It's also very hard to do that for a long period of time. And it's also up for people being malicious. So there's nothing to stop Charlie saying, Alice owes me $300. And you don't even know if Charlie put that into the ledger or put that onto the spreadsheet or anything. You would get around this kind of problem in the real world by having the ledger and have people just sign off on it, like a check, or just make sure that they're the ones that are doing the transaction. That's a bit more difficult in a digital world. In a digital world, you can just get a signature. A digital signature is just a picture or ones and zeros. It'd be quite easy to just copy that around everywhere. It's not simple, not hard. So how do you get around this? And this is the crux of how a blockchain works, and it's not really part of a blockchain, because a lot of the technology that's inside a blockchain is not new. It's just the way it's being used. And an easy way to do that, which most of you might know about, is public and private keys, or secret keys and public keys, like PGP or certificates. And what you would, and that's a public and a private key is essentially a wallet address and your private key to access and update that wallet address. If you want to sign something with a public key, with your private key, you would use a function called sign. And the key with sign is it takes the message, uses your secret key, and then applies it. And when it applies it, it creates a signature that's different depending on the message. So whatever message is there, the output is different. What's nice about this is if you want to verify that the person who signed this message is the owner of that secret key, you don't need to have their secret key. You just need to know their public key. Public key is very similar to like an email address or just like an online persona. And a private key is more like your password. And a verify function is using the message again, the output of the signature that you already got, and the person's public key. And all it does is output whether or not it's true or false, that it's been signed with their matching secret key. So it's very easy to verify who's done this. So that's the first step of a blockchain. So what you would do then is you'd use that secret key to sign your message, and you'd know that no one else could do it. But there's still issues with this even. There's nothing stopping someone getting that same message and just copying it over and over and over. Because it's the same message, it's the same signature. The easy way to get around that is when Alice does a transaction, she would just number each time she does a transaction, just adds it, and that would change the message entirely because it's including a number. So then your signature changes. Now, this is a good start, but it's not the end of it, because the other key point is who holds the ledger. Because if there's one person holding the ledger, there's nothing stopping them being like a bank and being that middle person that can be compromised or be corrupt or anything. There's also other issues too, like even if everyone is trying to be trustworthy, which ledger is the most up to date? Because if I said I was going to pay Charlie $100 and I only have 100, and then I said I was going to pay Alice $100, in between, which transaction comes first, which one is valid, which one is invalid? Because I don't have enough money to pay both. And this is where the nicety of blockchain comes into it. It's a concept called proof of work in most blockchains. There are other ones, but the main one at the moment that most blockchains use is proof of work. And all it essentially is a way of showing that someone has done a lot of compute power to maintain and update this ledger. And hence, there is less chance that they're going to want to corrupt or do anything untoward to this ledger. And the way to do that is using a cryptographic hash function, very similar to a public and private key, using a SHA-256. And a lot of people have probably already heard of it, like SHA-256 functions. It's the same kind of function that is used to secure most big websites, like banking websites, PayPal, pretty much anything with a little green padlock. What the trick is with this is, you get your SHA-256, you get your message, and you can put something else into it as well, and it puts out a hash or a digest that looks very random. It doesn't matter what it is, you don't know what it's going to be, but it's not random at all. It will always be the same for the same message. If I change anything at all about this message, like it says Bob was here, if I change it to Bob was here with a capital, the output changes completely, and you have no idea what it's going to be. So how do you turn this into proof of work? You get your ledger, you have a special number called a NOS, and the NOS is very random. It can be any number, it can be 1, it could be 0, it could be anything you want. You put that into the ledger, which then becomes your message. And you run your SHA-256 against this message until you get an output with a certain amount of zeros in front of it. And there's no way of knowing what number is going to create that amount of zeros. So let's say it was 30 zeros. That's a 1 in 1 billion chance of getting that. So the NOS number could be anywhere between 1 and a billion. So what happens is you'll run the SHA-256 with your NOS, check the output. If it's not correct, pick another number and try again. And just keep continuing this process, pick a number and try again. And that can take a long time or a lot of compute power. But to verify this, for someone who wants to check that you've done the work, they just get that NOS number and run it, and they'll get the same output that you've got. So it's a very hard way to do the work, but a very easy way to verify. So if anybody wants to look and verify you've done the work, it's quick. But to get that number can take a long time, or you get lucky, it can be quick, but generally can take a long time. Now, you wouldn't want to just do this every time you add a transaction to the ledger, and this is where you start to get the concept of blocks. So what you'll do is you'll get a bunch of transactions from people who are asking to transact between people, or if you want, you can do this, or someone else can do it. Bunch them together, put your NOS in there, and then send that block out to the network and say, is everyone happy with this block? Have I done the work right? Is there no issues? Am I not doing anything dodgy? But you still run into the same problem of which block comes first, which block comes last. You could put timestamps on this stuff, but there's nothing to say like at the moment a Bitcoin block is every 10 minutes or Ethereum's every few seconds. You could put blocks in between with a timestamp anytime you want and change what's happening. What you do is you get this special NOS number, and from the last block, you add it to the next block. So this NOS number that's taken a lot of work to find out which is the correct one gets added into the block, and it's become part of the message. So what happens then is it makes it very hard, because if someone tries to put a different transaction into the previous block, they have to recalculate the NOS, and then they have to create the new block and catch back up. If you've got a whole bunch of people still adding to these blocks continuously, you need a lot of work, a lot of compute power to actually catch up and get in front. The other thing too is it makes it impossible to put stuff in between. It doesn't matter about the time between blocks if it's short or long. You have to link up with the NOS numbers. So once you start getting this longer chain, if you wanted to change something back in time, it's almost impossible, because you'd have to have so much compute, and everyone would have to agree that they're happy with you owning all that compute and beating everyone else to create these new blocks and do all this work. It's very infeasible. At the moment, you can't call it a ledger anymore, because you're not just adding transactions continuously to the ledger, you're putting them into blocks and you're chaining together. So you have like a chain of blocks, and that's where you really get this a blockchain. Now, there is still one last thing that kind of a lot of people are working on and a lot of people are trying to improve, is a consensus. How do you make sure that if we had half the room here and half the room here working on creating blocks individually, there's a high chance that you'll come up with a block at the same time that is completely different. You could have different transactions in the blue block and different transactions in the green block, and they're both valid. It's just, you've just happened to come up to them at the same time. What the traditional method is now for most people in Bitcoin, Ethereum, and other blockchains is just to wait. Wait till someone else creates another block, and eventually what happens is one chain will start to fall behind or come out of sync because there's less compute power in one or the other. It's very hard to keep a balance for a long period of time. And so what would happen is your transaction could be in that first green block, or it could be in the blue block. It doesn't matter. Whatever you do is if you wait, say with Bitcoin, it's 10 minutes for a block. It could be 20 minutes before you're confirmed, or if it's a very high value transaction, you might want to wait up to like 6 blocks. And 6 blocks is just an arbitrary number based on some past history, but it could be an hour before you actually have a consensus, you're happy with the consensus. But there are other models. Proof of work is the main one that people use, and understanding how proof of work works makes it very easy to understand how people would do other consensus models. So there's proof of stake. Proof of stake is, instead of having compute power, you have ownership of an asset on that blockchain. It could be a token, it could be a coin, it could be anything, or just being involved in that blockchain for a certain amount of time. And the more time you have being involved in that blockchain, the more weight you have when you create a block. So if I've been involved in the blockchain for 2 years, when I go create a block, it's assumed that because I've been participating well in this blockchain for so long, that I'm less chance I'm going to do something wrong on it. So when I create a block, people are more than happy to accept that. The benefits of this is it uses much less compute power, it's much greener on the environment, it's much easier to scale, and it's kind of easier for people to join in. But the bad side is you can still have bad actors, the people who just have a lot of cash, buy a bunch of assets on that blockchain, or they may be early adopters and not really have the value of the chain could go up, or there may be that you want to have a blockchain that has no monetary value. It could be just a blockchain for security purposes that you don't necessarily need a proof of stake or a proof of work. The other one that I think is quite interesting is a DAG. It's a directed acyclic graph, and what happens is instead of a block of transactions or having a bunch of people mining, you have little nodes, and whenever they want to do a transaction, they create a block with their transaction and a previous transaction and split off to allow people to create blocks off that. It's not a direct chain like a proof of work or proof of stake that's all linear. It's more of like a tangle or a web of transactions. The benefit of a DAG is the more people that are involved, the more transactions you can create, because there's more devices creating individual blocks that could be at the same time, at different times, and they all get linked together in a web. One of the downsides of a DAG that people are working on is, at the moment, you need coordinator nodes to kind of make sure the DAG moves forward and not just turns into a sprawling mess. And also you need coordinator nodes to help index and make it searchable. Then you've got VMware's BFT, or scalable BFT. BFT is just a database language, a database consensus model that uses voting, and it has like a leader, and everyone votes whether the leader's block that is created is correct. And it's usually a 3-to-1. 75% of the vote needs to move it forward, and then the leader changes at random to somebody else. So with a BFT, you don't need to have proof of work, you don't need to have proof of stake, it's just a vote. So you can be very quick, you can create blocks on the fly, but it's more directed around having a private blockchain where you know who's going to be on it and you are happy to have them participate. Whereas if you have an open blockchain with BFT, it's a bit harder to make sure that you're not just getting people who are participating for the hell of it or giving them an incentive to participate. But currency is one of the very first and most obvious use cases for blockchain, because one, there's incentive to get involved, and two, there's a driver for people to incentivize them to maintain this blockchain. The next big use case that a lot of people are talking about is smart contracts on Ethereum and Neo and a few other blockchains. And smart contracts, or DApps, decentralized apps, are great, because if you think about it, once you have this ledger where you can put a message, it doesn't have to be a message of I'm sending money to someone or I'm sending a token to someone. It could be hello, it could be code, it could be whatever you like. And that code gets distributed to everyone who's involved in that blockchain. And if you create a structure around the blockchain that you can execute this code from within the client that runs it, you can create distributed apps without having to have them hosted centrally, managed by anybody, and they can't be changed or plugged in with a middleman. So like if you're on an app store now and you download an app onto your phone, there's nothing saying someone compromised the app and then uploaded code to it, or you don't know what's happening with it. With a smart contract, you can see the code, you can make copies of it and change it yourself, and it's a new contract. If there's a bug in the code, you create a whole new contract off that with a fix in it. People just start using the new contract. But you can do very cool things, like I've seen music created in a smart contract that every time it gets played, you have to pay a fee to the artist. And if you send that music on to someone else, that contract's still valid. So the artist still gets paid royalties no matter who plays the music or who resells it. And there's plenty of other uses, like kicking off of wills, managing deeds, being an escrow service. There's smart contracts that create whole online exchanges for transferring different tokens between people without having to go to a central authority. The one I like the most at the moment, which gets me excited, is IoT management and endpoint management. Because a lot of businesses who want to run IoT, there's lots of different devices from different vendors and different specs and different levels of compute power. And having a secret key and a public key handed out to a IoT device, it's very easy to secure them, to send the data encrypted, or to manage the identity of it. And if it gets compromised, you can just send out a new private and public key. And on that, there's not much difference, I personally don't think, between endpoint management and identity management. So like in the US now, everyone uses social security numbers and has had them compromised. Having a secret key and a public key, where you use your public key as your identifier, but if you want to do anything with your private key, or sign up for a loan, you need to have access to that private key. If your private key gets compromised, it's very easy to reissue a new private key and public key and link them to the old one. And if anybody tries to sign anything with your old private key, it's invalid. But all the transactions you've done before are still valid. And I think that's a great use case. You could do things like online voting, apply for your taxes, do loans, and you don't even have to then do full KYC by handing all your information to a third party. As long as they see that you can sign a transaction with your public key, you can prove that who you are, and they can hold whatever information they want, they can gather it, you don't have to give it to them. It also helps with things like verifiable claims of insurance, making sure no one has applied for insurance anywhere else. They can just do a register and say, how many insurance policies does this public key have? But they don't have to go, give me your private key to figure that out. The other use case that's getting a lot of traction is asset tracking. Because this blockchain, once you put a message into it, it's very hard to change or infeasible to change. If you wanted to send goods to the other side of the world to another company, you can put the manifest into the blockchain, it's locked in, and when they get to the other end, the company that's getting it can be quite sure that you haven't tampered with the message in transit. So you're knowing what you're getting and you can confirm it. And I think it's a great use case, very easy. But my thing is, the blockchain is very much like the internet of the late 80s, early 90s. It's still very new. All the use cases people are thinking of are trying to fix current problems today. But there are lots of use cases we haven't even come up with. Like the early webcam, first use of a webcam was to monitor a coffee pot. If we based all our webcam development off coffee pot monitoring, we wouldn't have phones in our pockets, we wouldn't have YouTube, we wouldn't have Netflix, or all online video streaming, and plenty of other uses for digital video. And I think that's the same case with Bitcoin and blockchain, is that there will be killer apps that no one would have thought of, or use cases that just change the world, because you'll have very different ways to do this. And that's it, guys. That's very simple. And I know I've skipped over some stuff and I've crunched some things a bit, like block rewards. If anybody's got any questions, I'm more than happy to answer them. Yeah? Yes, DAGs.
The DAGs are getting constantly, the size of DAG is getting increased. Because of that, when we have started mining, there are lots of loss. The acceptance rate is getting lower and lower. So the mining is getting more and more.
Yes. There is definitely, and I think that's an issue with all blockchains. And what the question was is, DAGs, as they get bigger, there's a lot more information in them, and it takes a lot more to mine, a lot more to manage, and to get involved into it. The same with proof of work and proof of stake. Because you're keeping transactions for all of time, the longer a chain has been around, the bigger it is. And if you want to get involved and start working with it, you have to download the transaction, because it's a transaction log, just like a database log. It's like having a database without having an actual database, just a transaction log to replay everything that's happened. And that is one of the big downsides at the moment with most blockchains, is how do you purge these old transactions that aren't needed anymore, or how do you just hash them out? People are doing things like, instead of sending out the blocks to everyone, you get the hash of the block, and if you need to look up the transaction, then you download that block as you need it. So there's ways around it. There's plenty of people trying to work on better ways to do it, or working out whether or not you can, if I've transferred an asset to you and then you've transferred it to somebody else, there's no need to have the record of me transferring the asset, just the last one. So there's people looking at trying to prune out old transactions and then trim down the blocks and just send the information you need. So there's lots of things like that. Yep.
Blockchain will eventually replace the money. Actually, the money is controlled by the government. Do you think one day the blockchain will be under control by the private or the government?
So the question was, blockchain could probably replace money in the long term. And I think, and will it be controlled by government in the long term? I don't think it needs to be controlled by government. I think that's the beauty of it. People think you need to have it backed by gold or backed by something else. It's backed by the value of what people perceive of it. And that's the same with gold, the same with the US dollar. It's backed by what people perceive the value of it is, not by a government backing it. That's why price fluctuates in all fiat currencies, and that's why price fluctuates in things like Bitcoin. I think as long as a government can use a currency to do tax or do anything at all, that's enough. I think once governments come to terms maybe with that, we'll see a lot of turning around. Like Venezuela is using Dash as an official currency at the moment, and that's being well used. The other side is around privacy. If you're doing transactions, everyone can see them. There are some privacy coins. Whether they are feasible long term is a different story. I think that's all the time I've got. Thanks, guys.